So we will derive the power in AC circuit. So in DC circuit, how we calculate power? In DC circuit, suppose this is a DC circuit here. This is the resistance and this is connected with a cell or a battery. Basically, a cell or a battery is a DC source. Okay, so this is a DC circuit. So in DC circuit, resistance is connected with the DC source. There will be current. So power can be given by the product of voltage and current. Okay, power can be given by the product of voltage and current, or it can be given by power is equal to V square by R, or it can be given by P is equal to I square into R. So this is the case for the DC circuit. So in DC circuit, it is very easy to calculate the power. But in case of AC circuit, actually what happens in case of AC circuit, the current and the voltage is changing continuously with time. Here, in case of the DC circuit, the current and the voltage are constant, not changing with time. But here, current is also changing with time in AC circuit, and voltage is also changes with time. Okay. So what we will do? How to calculate the power? The question is how to calculate the power. So in AC circuit, the power will change with time. Why? Because current and voltage are changing with time. So earlier we have seen that EMF was also changing with time. In AC, EMF is also changing with time. That is, voltage is also changes with time. V is equal to V naught sine omega t. Omega t, this t is time. We know that this time is changing continuously. So the voltage in alternating circuit or AC circuit changes continuously. So what we do, we calculate the average voltage. We calculate the average voltage or root mean square voltage. Okay. So here also we will calculate average power. Here also we will calculate the average power. Why we are calculating the average power? Because at each and every time after mean with time the power is changing. Simple. So suppose at any time t in this circuit, the voltage is given by V. I have written like this: B suffix t, B in bracket t. What does this mean? This voltage is a function of time. Means voltage is changing with time. So V voltage at any time t is equal to V naught sine omega t in this series LCR circuit or AC circuit. And I have supposed current as I is equal to I naught sine omega t plus phi. Okay. So this is the equation of the current. So what is phi? Phi is the phase difference. I have told you there is a phase difference between the current and the voltage in AC circuit. Sometimes the phase difference is zero also in case of purely resistive circuit. Okay. So power at any time in this circuit is given by voltage at any time t into current at any time t. Power is equal to voltage into time current at any time t. Okay, now put the value of this Vt, put the value of this It. Vt is this, V naught sine omega t, It is this, I naught sine omega t plus phi. And we want the average power. Okay, so one thing I want to tell you, you can note here, this thing here. You can note this thing here. Average. See here, average can be represented. Suppose this is also the average power. This is also known as the average power, or we can write average power as P and this bar. Okay, this is also average power, or simply we can write P average, P suffix average. So this is PT, this is power, and this bar means average power. So you will take the bar on whole of this, you will take the bar on whole of this. Okay, now this thing I will tell you later. This thing I will tell you later. Okay. So I am taking the bar. Here is also the bar. On this whole V naught I naught sine omega t, like this. Now see. So basically here is one bar like this. And we have V naught I naught. We have this V naught and we have this I naught. This is sine omega t. Remember one thing. There is a formula. There is a formula that I am writing here. If it is written as sine of A plus B, sine of A plus B, this is a formula from the trigonometry. It can be written as sine A cos B plus cos A sine B. So this is sine omega t plus phi. So with the help of this formula, we can write it like this. Sine omega t cos phi, sine omega t cos phi plus cos omega t sine phi, and bar on whole of this. Now what we will do, this is the whole bar. Bar means average. So this is V naught, this is I naught. Now what we will do, we will multiply this sine omega t with this whole bracket. So when you will multiply this sine omega t, so it will become sine square omega t cos phi. It will become sine square omega t cos phi plus what you will get here, sine omega t cos omega t sine phi. Sine omega t cos omega t sine phi. Okay, now this is the whole bar. This is V naught. This is I naught. This is sine square omega t cos phi. Sine square omega t cos phi. And here I am multiplying with 2 and dividing it with 2. So it will become sine omega t cos omega t sine phi. Okay. There is one formula. There is one formula that you should remember. 2 sine A cos B. 2 sine A sine cos A. 2 sine A into cos A. 2 sine A into cos A can be written as sine 2A. Sine 2A. This is a formula of trigonometry. So we will use this formula here. So basically see this portion. See this. 2 sine omega t cos omega t. 2 sine omega t cos omega t. We can write it as sine 2 omega t from this formula. Okay. So this is whole bar here. Here is V naught. Here is I naught. Here is sine square omega t. Sine square omega t into cos phi. Plus this will become half this thing. 2 sine omega t cos omega t can be written as sine 2 omega t. Sine 2 omega t. And this is sine phi, simple. This is sine phi, simple. Okay. Now we will distribute this bar on this and on this. Okay, so it will be like this. So I am writing here. This will be V naught and I naught bar and bar on this. Sin square omega t cos phi plus half of sin 2 omega t, sin 2 omega t into sin phi. Now further, see this V naught and I naught are the constant. And what does this mean? Bar of V naught I naught. Bar of V naught I naught means we can just separate it. We can write it V naught bar into I naught bar, and we can apply the bar on this and this. We can write this like this: bar on sin square omega t into cos phi plus half, and this is bar sin 2 omega t into sin phi. Now, what is the meaning of V naught bar? What is the meaning of V naught bar? Means average. I have told you we represent, if I am writing resistance and bar, it means average of the resistance. Average of the resistance. Okay, average of the resistance. So basically, this is V naught. V naught is the V naught bar is the average value. I naught bar is the average value of the peak. And if something is constant and you are taking the average of that, for example, this 2 number is constant and you are taking the average of 2. Suppose you have 4 2s and you want to find the average of 2 divided by 4. Again, you will get 2. Means the average of constant is constant. So average of V naught will be V naught. Average of I naught will be I naught. Here the bar will be distributed to sin square omega t. Means what is the meaning of this? Average of sin square omega t for full cycle. Average of sin square omega t for full cycle. Basically, we are calculating the power in AC circuit for full cycle. Okay, for full cycle. For full cycle. And this is cos phi bar. Cos phi bar. This is plus half, and this bar will be distributed on sin 2 omega t. So this is sin 2 omega t, and this is bar, and this is sin phi, and this is bar. Now this is V naught, this is I naught. Now what is the meaning of bar of sin square omega t? Means the average value of sin square omega t for full cycle. See, bar of sin square omega t is equal to half. This is the shortcut that I have told you. So here I will write half. And this is cos phi is the constant. Cos phi is constant. Why? Because this phase difference is constant. That is why this cos phi is constant. And bar of constant is same. This will become cos phi plus this is half. Now see here, average value of sine over full cycle equal to 0. This is sine 2 omega t. So average of sine over full cycle equal to 0. So you can write here average of sine omega t, sine 2 omega t, 2 omega t is equal to 0 for full cycle. All these things are valid for full cycle. So it will be 0. And this will be sine phi. Why? Because this phi is constant. So now this whole thing will be 0. What we have? We have V naught into I naught divided by 2 into cos phi. This will be the average power we have. We have average power. Okay, this is basically the average power. P average. Okay, now there is a relation between the root mean square value. There is a relation between the root mean square value and the peak value. V of root mean square is equal to peak value of voltage divided by root 2, and IRMS is equal to I naught divided by root 2. So from here, can we find the value of V naught? So V naught is equal to root 2 times of VRMS. And I naught can be written as from here, from this equation, root 2 times of IRMS, root 2 times of IRMS. Now put the value of VRMS and IRMS here. So the average power is equal to V naught is root 2 times of VRMS multiplied by I naught is root 2 times of IRMS into cos phi, this whole divided by 2. Now see, this root 2 and root 2 is multiplied, becomes 2, and 2 and 2 will be cancelled out. So average power will be VRMS IRMS into cos phi. Basically, this is the average power of the circuit, AC circuit we will get. Average power. Now I am telling you one another method to solve for the average power. That is very lengthy method, according to me. Note. Average power for the full cycle can also be calculated with the help of the integration. Like we have calculated the average EMF. Okay. So in that case, you have to integrate this function. Okay, and this will become very, very lengthy for you. So this is basically a better way to solve for the average power. Okay. Now this thing, this cos phi is known as the power factor. This cos phi is known as the power factor. Because this is a factor of the power. Okay. So this is power factor. So now power factor. Now already I have told you these things. Power factor we will calculate for different circuit. First circuit I have told you the pure resistive circuit. So in pure resistive circuit, the current and the voltage are in same phase, means phase difference phi. What is phi? Phi here is the phase difference. Okay, phi is phase difference between the current and the voltage. Phase difference between the current and the voltage. So in case of purely resistive circuit, I have told you phase difference is 0. So phi is 0, means cos phi is 0. What is cos phi? Cos phi is power factor, so power factor is equal to 1 in case of pure resistive circuit. Now pure inductive circuit, what is the phase difference? 90 degree. What is the power factor? Cos 90, 0. So in case of purely inductive circuit, sorry, not resistive, inductive circuit, the voltage leads the current by 90 degree. So phase difference of 90 degree. What will be the power factor? Power factor will be cos phi. Phi will be 90 degree. Cos 90 is equal to 0. Same is the case with the capacitive circuit. Okay. Here current is leading the voltage by 90 degree. Now in case of LCR circuit that we have studied, in case of LCR circuit, in LCR circuit, suppose I am just considering the inductive reactance. Okay, in LCR circuit, what was the impedance diagram or phasor diagram? Phasor diagram is like that. In this direction, resistance, here is your XL, here is your XC. If I am saying, for suppose XL is greater than XC, then this diagram changes to this diagram. This is R, this is XL minus XC, and the resultant of both will be the impedance Z. Z will be the impedance of LCR circuit. and this angle is phi. This angle is phi. Now in this case, how you will calculate phi? How you will calculate phi in this case? So cos phi in case of series LCR circuit, this distance, this is a triangle, na? This is a triangle. This is a triangle. Okay. So in this triangle, basically this triangle is known as the impedance triangle. So why we say it is as impedance triangle? I have told you in the beginning, the length of the arrow will be this. This will be the length of the arrow. Okay. And here Z is the length of the arrow. So if I am taking this triangle, suppose this is O, this is A, and this is B. So if I am taking a triangle OAB, so this is O, this is A, this is B, and this angle is phi. And this OA length is Z, and this length is XL minus XC, and this line is perpendicular parallel to this line. So this is also XL minus XC. AB is also XL minus XC, and this OB is equal to R. OB is R. So now from here can we find the cos phi? Cos phi is base by hypotenuse, that is R by Z. Cos phi is equal to R by Z. So this is the case when your XL is greater than XC. If I am saying in the circuit XC is greater than XL, then what was the phasor diagram? Resistance you have like this, and you have XC minus XL, and resultant here Z, and this is the phi. So in this case also, with the help of the geometry, you can find R by, cos phi, that is R by Z. Okay, R by Z. So Matthew and Nafisa,
Yes, sir. No doubt.
Yes, sir.
are you getting?
Yes, sir. Understood.
Yes, sir.
Okay, so just uh, note down this, and just a minute. Actually, I have to write this here, and I am zooming it in. Okay, so now you can write down. And when completed, you can ask me to scroll down. Basically, na, this is the bar. This is the bar on this function. Okay, on this function. This. So after 25 minutes, okay, I will leave the class because I have some work. I have to go somewhere. Okay, so I will compensate this in the next class. Okay, Matthew and Nafisa.
Yes, sir.
Yes, sir.
Yes, sir.
Actually, I have to go somewhere. So we will compensate.
So, sir, next class you'll take more time.
Yeah, of course I will
All
take.
right, sir.
Actually, I will take half an hour more in the next class. Okay. So
Okay, sir.
because today I am leaving the class early, na. So
All right, sir. No problem.
hmm.
Sir, you can scroll down.
Nafisa, should I scroll down?
Yes, sir.
Okay. So this derivation I know is looking very complex, but believe me, when you will do it 2 times, then it will be very, very, very simple. This thing I have written so that when you will revise your notes, you will get the point that, oh, sine omega t is equal to 0, average value of sine omega t. Okay. So AC will be finished in the today. I think uh, it will be finished in the next class definitely. Alternating current, because there is one topic left, two topic left basically. One is the resonance. I think resonance we will complete today, and another topic is the transformer. And there was one more topic, LC oscillation. LC oscillation, very, very interesting and very important topic, but this that topic deleted from your syllabus, so we will not discuss that. LC oscillation. Basically, in LC oscillation, what happens? Uh, because of the LC oscillation, there is a production of the electromagnetic waves. So basically, average power we are discussing for the full cycle. Full cycle means for the time 0 to t time period. 0 to capital T time period. We are discussing the power. And why we are calculating average power? Because here power is variable. Why? Because voltage and the current are changing with time. They are alternating current and alternating voltage. When completed, you can ask me to scroll down. And as your exams are approaching, so I will give you the advice that now focus yourself only with the study, okay? Because after 12th class, your life will be different, okay?
Sir, it's over. Scroll
Hmm.
down.
Scroll down.
Yes, sir. Finish.
So basically, few days are left for your exams, and after the 12th, basically, depending upon you what you will do, you will become a doctor or engineer or anything else, but right now there is a time to do hard work. So Matthew, when will be your final exams?
So maybe like almost the end of February or like mid-February.
Mid-Feb, means I am just supposing at the end of the Feb. Okay.
Done, sir.
Nafisa, completed?
Yes, sir. Finish.
Okay, right on there. So suppose if a person, you write down, just I am telling something. Suppose if a person want to be a footballer, then whether he should play a cricket or football, he should play, he should play football. Like that, if you want good marks or you want to be good in chemistry, in physics, in biology, in maths, in computers, coding and all that, so you have to do that. There is a simple funda. There will be the difficulties uh, when you will study physics. For example, you are studying a physics or a chemistry, you will have doubts, because uh, according to me, we all have doubts. Teachers also have doubts, because teachers also are the human beings, and a human being have the limited capacity, okay? So we all have doubt, we all have the difficulties, but the main thing is the goal, what we want to do. So your goal is important. no matter how much time you are giving to your studies. But if you are giving suppose 3 hours, so give that 3 hours. In that 3 hours, give your 100% at least.
So can I explain again how purely capacitive circuit the theta is 90?
In purely capacitive circuit, the theta is 90. Okay.
Yeah, how is it?
Okay, first note down the whole thing, then I will explain. Okay.
Alright, alright. Just so you can scroll down.
Nafisa, should I scroll down?
Yes, sir.
Okay.
Done, sir.
So in purely capacitive circuit, what happens? In purely capacitive circuit, so this is the capacitor and this is connected with an alternating source. This is a purely capacitive circuit, and this is a voltage, and there will be some current. Suppose I is the current at any time. So we have done our derivation, so I am not going to do the derivation here. It will take time. So I have told you the equation of the voltage. I have written there V is equal to V naught sine omega t. And from this equation of the voltage, when we get the equation of the current, we get the equation of the current I is equal to I naught sine omega t plus 90 degree. So that is why according to equation, when you will draw the phasor diagram, so your voltage is in this direction. This will be the, suppose this is one axis, this is another. Okay. So if this is your voltage, phasor of your voltage, this is V naught, okay, and this is making an angle omega t. So the current, I have told you, current will lead 90 degree. So this will be the current I naught, and this angle will be 90 degree. So in purely capacitive circuit, the current is leading 90 degree. So that is why here current is leading. Now got it, Matthew? Matthew, got it?
Yeah, sir, yeah, understood now.
Okay, so okay, now completed this part.
Yes, sir.
Okay, added 2 more points here. These points, add these points. If in question, if nothing is given, so you will assume the average power. If in question nothing is given, then you will assume most probably root mean square current and root mean square value of the voltage or current. If any voltage is given, suppose in the circuit, and name not written like this is the average, instantaneous, or root mean square. Then in that case, you will take the root mean square voltage. So this point I will tell you from where this is the Nafisa. You do not have any doubt?
No, sir.
Okay. Okay, so completed.
Yes, sir.
Just
Okay, so formula we get of power is VRMS IRMS cos phi. So average power is basically V root mean square multiplied by current root mean square RMS into cos phi. And what is cos phi? RYZ. What is cos phi? RYZ. Cos phi will always RYZ. So put this value and get this answer. VRMS IRMS cos phi is RYZ. Write down.
done.
Done. Okay, so tell me, Matthew, what is the relation between the root mean square current and the root mean square no, peak value of the current and the root mean square current? Just think.
It's like directly proportional.
Yes, you are right. But what is the value? How you will write? Like I am saying, write VRMS in terms of peak value, root mean square. So basically we write like this, na, V naught by root 2.
Yeah.
If I am asking Nafisa, what is IRMS?
I
How
not
can we
by
write IRMS? I naught by root 2? Okay.
Yes, sir.
I naught by root 2. Okay. So we will do revision first. I think there is a requirement. And next class, we will compensate that. So basically here, basic things you should know. In series LCR circuit, what is the impedance? Z. Impedance Z is equal to R square plus XL minus XC square. Okay. What is XL? Capacitive or inductive? What is XL?
induction.
Nafisa, what is XL?
Inductive.
No, inductive. What is it after inductive? Inductive reactance. This is inductive reactance. Okay. And this inductive reactance is equal to omega into L. What is omega, Matthew? And what is L? What is omega and what is L?
L is inductivity and
Yeah,
omega was
angular frequency.
yeah, angular frequency.
Omega is angular frequency. Okay, and Xc, Afisa, do you know what is X suffix C?
Capacitive reactance.
Capacitive reactance. Capacitive reactance. And Xc is equal to 1 upon omega C. What is C? Capacitance of the
Capacitance.
capacitance of the capacitor. So this is the impedance. Z is known as the impedance of the impedance. Now, for purely resistive circuit, what will be the phasor diagram if I draw? Take two axes.
Yeah, V not and I mean V and I will be
Same
both,
direction.
yeah, same direction.
Yeah. So suppose this is the peak value of the voltage and this is also the peak value of the current. So you can say current and the voltage are in same direction. Now for the purely inductive circuit, the phasor diagram will be like this, purely inductive circuit. So for that for the phasor diagram we should know the equation of the voltage and equation of the current. So equation of the voltage we have taken this, equation of the current we have taken I is equal to I naught, not taken, we got this equation omega t minus 90 degree. Okay, so basically suppose this is your V naught and this V naught is making an angle of omega t, then this current is lagging behind the voltage by 90 degree. This is I naught. Okay, if you will take the projection of this I naught on this y-axis, then you will get the instantaneous value of the current. If you will take the projection of this voltage on this axis, then you will get the instantaneous value of the voltage. For the capacitive circuit, purely capacitive circuit, what is the condition? This is for the purely capacitive circuit. So suppose this is your V naught and this is omega t. So equation of voltage is V is equal to V naught sine omega t, and equation of the current I is equal to I naught sine
omega t
plus 90 degree. So current is leading the voltage by pi by 2. So current will be like this. This will be I naught and this whole angle will be 90 degree. Whole angle will be 90 degree. And if we draw the phasor diagram for the series LCR circuit, then the phasor diagram for the series LCR circuit in terms of the resistance and the reactance, then it will be the, so resistance is like this, I have told you, and XL, this will be XL, capacitive reactance, inductive reactance, this is XC, capacitive reactance. Okay, this type of diagram. In terms of the voltage, so this is V naught, peak voltage across the resistance, and this is V naught of L, peak voltage for inductor. This is V naught C, peak voltage for the capacitor. Okay, so accordingly this diagram, both these phasor diagram will change when XL is greater than XC or when XC is greater than XL. Okay, what happened?
So
Oh, just a minute, actually. What is okay? And